Hello guys, today we are talking about for linearization about y equals to a times x power of p. Okay, so for this kind of problem, we can just first log on both sides. So when you just log on log y, and it will becomes log y, and we are just log on a times x power of the p, it becomes log a plus log xp, right? Because we said log a plus log b equals to log ab, right? Okay. And also you can find here log x power p, you can put p before that. Okay, so it will becomes into log y equals to log a plus p times log x. Okay, so here you can just let log x as a capital letter x and log y as a capital letter y. So it becomes into y equals to c, and let the log a equals to c. Okay, so it becomes into y equals to c plus mx. Okay, y equals to c plus mx, where the y equals to log y and x equals to log x. Okay, that is it. Okay, sure. So also we can say for this kind of problem, like if you want to calculate the gradient p, we can just find 2 points like capital X and capital Y. Just consider as log x1, log y1, and log x2, log y2, right? So we just put into it. So we will find the gradient p equals to the log y2 minus log y1 over log x2 minus log x1. Okay, that is how we can calculate gradient here. And for example, like here we have y equals to a power of y equals to a times x power of p. We can just put the 2 point, 0 point, negative 0.68, 3.02, and this point into it, okay? So we can say like it's that the log y and log x is a straight line passing through this point. So we can just set first, just calculating the logarithm here. So we can just first trying to find the logarithm. So log y equals to log a times x power p. So it becomes into log a plus p log x, right? So we can say here that if we want to calculate the gradient p, we can just using like p equals to the gradient. So it's for 3.02 minus negative 1.53 and negative 0.68 minus 1.07, right? That is for gradient p. And after we calculate p, because we have 1 point like log x1, log y1, we can put it into this function because we already know p, we can calculate for log a, right? And then using calculator, you can calculate exactly what is for the a value, right? Okay, that is for this kind of problems. Okay, sure. And also, for example, like here, we can just calculate p equals to negative 2.6, right? That's the gradient. And also you can calculate into a here. Okay, so a equals to 3.50 here. Okay, that is how we can calculate for such problems. Okay, so maybe for this problem like Q1, we can set here if y equals to a times x power of p and finding the graph of log y against log x passing through these 2 points, right? So we can set here first calculating log. So it's log y equals to p log x plus log a, right? So you can calculating the p and log a because you just let log y equals to y, log x equals to x, and log a equals to c. So it's y equals to px plus c, right? So p equals to this 2 points gradient. So it's for 2.43 minus 3.96 over 1.32 minus 0.22, right? That is a p's value. And after calculating p, you can calculate it for log a and then find exactly what's the value here. So you can find a and p. Okay. So maybe if you have p's value here, and you can put it into maybe the first question here is for 3.96 equals to p times 0.22 plus log a. And already you know the p, right? So you can calculate the a's value here. Okay. And also for question 2, if y equals to a times x power p, to explain why log y against log x is a straight line. So first, you can just logarithm on both sides. So y will becomes into log y, right? And a times x power p will becomes into log a x power p, right? And then we can simplify a little bit. So it's log y equals to log a plus log x power p. And then put p before it, so it becomes log y equals to log a plus p log x, right? Okay, that is it. That is for this problem. Okay, so that is for this problem. Hope you can truly understand for this, and I hope you can understand what is the lines and the relationship between the y equals to a power times x power p. Okay, so that's for this our lesson. See you next time. Bye.